Hey guys, in this video we're going to talk about Chapter 3, Section 2 in the textbook, the vertex of a parabola. So recall that last time we talked about the standard form of a quadratic. It's of the form f of x equals ax squared plus bx plus c, where a, b, and c are all numbers. So one true thing is that if your number a in front of x squared is positive, your parabola opens up like this. And if a is negative, it opens down like this. So for example, the parabola y equals negative 2x squared plus 4x minus 1. Since this a is negative, it opens downward like that. And you can verify this with Desmos. But if we have a positive number such as 2x squared, well, since it's positive, it's going to open upwards like that. So that's the information that standard form really gives us. We also looked at factored form. So recall that factored form, we have a times x minus z1 times x minus z2, where z1 and z2 are the zeros. That's where the graph crosses the x-axis. So for example, in this picture that I have right here, our first zero, or z1, would be negative 1, and our second zero, z2, would be positive 2. And this a is really the same as the a in standard form. So if that a is positive, well, the same thing applies. It opens upwards. And if it's negative, it opens downwards. So that's what that a coefficient is going to tell us. The next type of form that we're going to look at for quadratics is called vertex form. And vertex form, it kind of gives us the it gives us the vertex, which is either going to be the highest or lowest point on the parabola. So let me write that out. So the vertex is either the highest or lowest point on the parabola. All right. And this is the form. It's a, where a, again, is going to tell us where it opens up or down, depending on if it's positive or negative, times x minus h squared plus k. And the ordered pair h comma k is the vertex, and x equals h is the axis of symmetry. So let me explain what that means. Here we have a function graphed on Desmos, and the vertex form is again a times x minus h squared plus k, where h comma k is the vertex. So the vertex is either the highest or the lowest point. Does this guy have a highest or a lowest point? Well, it has a lowest point because it keeps going up forever and ever without bound. So this is the lowest point, aka the vertex. So here our first number in the ordered pair is h, and our second number is k. So h is equal to 1, and k is equal to 3. That's our vertex. So, and then we can see in the equation that the a value is just 1 because there's no number written in the front. So that's understood to be 1. So here a is equal to 1. And that is vertex form. So if we had, let's say we had a quadratic that looked like this. Well, if it's concave down like that, our vertex is going to be at the top. This is going to be the highest point. So that is the difference there. If we're concave up, our vertex is the lowest point. If we're concave down, the vertex is the highest point. And what about this axis of symmetry? Why do they call it that? What is that? Well, the axis of symmetry is just the line that goes through the x-coordinate of the vertex. So it's going to be a vertical line like this, and it's called the axis of symmetry. Oops. So this is the axis of symmetry. And it's called that, let me erase some of this, because it divides the parabola into two equal pieces. The left piece on the left side and the right piece on the right side of the axis of symmetry. So the axis of symmetry goes through the vertex. It's a vertical line of the form x equals h, where h is just the first number in our vertex. And it divides the parabola into two equal pieces. The green piece and the orange piece in this case. That's why they call it the axis of symmetry, because the pieces are symmetric or equal. Okay, so let's do some practice with this. We're going to identify the vertex and the axis of symmetry, and we're going to see whether the graph is concave up or down based on the a value and also the y-intercept. We're going to figure out what that is. So the first thing is the vertex. I'll write vertex form over here. We have a times x minus h squared plus k, where h comma k is the vertex. So let's look at our first example. Here we can see that the h value that matches our formula is 4, and our k value that matches our formula is positive 1. Therefore, our vertex is 4, 1. The axis of symmetry goes through the vertex. It's at x equals h. And we just established that h was 4. Therefore, our axis of symmetry is at x equals 4. Concave up or concave down. Remember, this depends on a. A is -2, right? That's our number that's attached in the front. And since a is negative, this is concave down. If it was positive, it would be concave up. All right, so let's just kind of square our answers. And the last thing is the y-intercept. The y-intercept happens when x is 0. Let's write that down. Or how about the input? That's a better way to put it. So if we plug in 0 into our equation for our input up here, let's do that. F of 0 is equal to -2 times 0 minus 4 squared plus 1. And if we simplify this guy, we get -2 times -4 squared plus 1. Therefore, -2, we get -2 times -4 squared is 16 plus 1. So this is -32 plus 1, which is -31. So this is our y-intercept. Now, if we were to sketch this thing, just based on the information we just found, what would it look like? So this is going to be a very rough sketch, you guys. Well, here's our y-intercept at -31. We know the vertex is at 4, 1. So 1, 2, 3, 4, up 1. So this is 4, 1. And we know that it's concave down. So maybe it looks something like this. So So that's just a very rough sketch of what we just found out. All right, let's do another example. I'm going to erase some of this, so let's go ahead and do that so we have more room. Let's do another example. And I encourage you to pause the video and see if you can do this one on your own. This time our input variable is t. That's no problem. We just treat it like it's an x. Now the vertex, if we look at our basic form up here, we can see that in the h spot is 1 and in the k spot is -6. So this is going to be 1, maybe I'll do it in, let's do it in green, yeah. 1 comma -6. The axis of symmetry is at x equals h, so this is going to be at x equals 1. That's where it divides the thing in half, the parabola thing. Concave up or down, that depends on a. A is a positive number here, so this is concave up. Smiley face, right? Y-intercept happens when x is 0, in this case when t is 0. So the y-intercept, I'll do my scratch work over here, is just going to be 1/4 times 0 minus 1 squared minus 6. Again, I'm just plugging in 0 for my input variable. And if I simplify this, oops, oh, here we go. Let's see, why is these people calling me? Sorry, you guys. Getting a weird thing here. Okay. So anyway, we get -1/4 times -1 squared minus 6. -1 squared is +1. 1/4 times 1 is just 1/4. 1/4 minus 6, well, you can use your calculator. You can find common denominators. I'm very lazy, so I'm going to use my calculator here. Let me turn my phone off. People just want to call me right now. Well, I'm trying to make this video for you guys. All right, there we go. All right, so when we put this in Desmo Scientific Calculator, which you can find online, you get -23/4. That's my y-intercept. Which as a decimal is about it's -5.75. -5.75, if you like that better. So if we were to just, do a very rough sketch of this thing, let's do that. So this is, I'm going to write this down here. Our y-intercept is -5.75. If we were to do a very rough sketch, we would get, well, I always start with the vertex. So the vertex is at 1, -6. So when x is 1, y is -6. 1, 2, 3, 4, 5, 6. So that's about right here. It's our vertex. Oops, not -1, 1. And our y-intercept is -5.75. So it's like really, really close to the y value of this vertex. So maybe it's like right here or something. It's concave up. So we could figure out what another point is, but since the axis of symmetry divides it into equal pieces, we know that we're going to have another point that's kind of close like that. So if we were to just do a very rough sketch, and we'll do a more precise sketch in the next slide. But yeah, that's kind of what it looks like. We can always verify on Desmos. It's such a handy tool for this kind of stuff. So, all right, there it is. Now let's do this next example. First thing is the vertex. Now, if you ever have a positive for your h, you want to make it a negative, okay? And the reason is because the basic formula is x minus h squared plus k. So in order to produce a positive, that original h had to be negative. I hope that makes sense. If it doesn't, just remember opposites for h. So here, since it's +4, we want to make sure that it's -4. We write our vertex there. And our k is just going to be as it is. It's positive 2. We don't switch signs for k. But notice that, for our previous h's, we had a negative 1, so we made it positive here. And then for the first one, we had a negative 4, so we made it positive here. But the k's are just how they are. So, all right, so that's our vertex. Our axis of symmetry is going to be at x equals h. So this is going to be at x equals negative 4. It's where it divides the parabola in 2 equal pieces. And it's going to be concave down because our a value is a negative 1. So this is concave down. Our y-intercept occurs when the input is 0. So we have y equals negative. I'm plugging in 0 for my input x. And I'm seeing what I get out for my y value. So I get negative 4 squared plus 2. Exponents come before multiplication, so 4 squared is 16, so this becomes negative 16 plus 2 is going to give me a negative 14. So this is my y-intercept. If I wanted to write this as an ordered pair, by the way, I would write x is 0, y is negative 14. Same thing up here. X is 0, y is negative 5.75. So let's go ahead and just sketch this out based on our information. We don't have to make it perfect and exact, just on what we have here. We know that the vertex is at negative 4, 2. So 1, 2, 3, 4, up to 1, 2. So that's right here. Here's my vertex. Our axis of symmetry is going to divide this thing in half. I didn't do it in the other ones, but why not? It crosses the y-axis at negative 14, so maybe that's right here. I don't know. So maybe it crosses right there. And then since the axis of symmetry divides it in equal pieces, we know we're going to have an equidistant point right over here. And it's concave down. So there it is. Oops, didn't even hit it. Guys can tell I'm a great artist. No, I'm just kidding. I'm actually a terrible artist, but that's why I went into math. So vertex, y-intercept, and then just another random point that we found because a parabola is symmetric on both sides of the axis of symmetry. Let's do some more examples and then we'll move on. Okay, so here again, we have a positive in here, so we're going to make it negative just because our original form is a negative. And like I said, in order for the h to be positive, or in order for this to be positive, we have to have a negative h. That's what's happening here. So our vertex is going to be negative 1/3. That's our h, and our k is going to be negative 5/6. Axis of symmetry is at x equals h, so this is x equals negative 1/3. Concave up or down, well, our a value is 5. That's positive, so this is concave up. And our y-intercept, we're going to plug in 0 for x into our original function, so we get 5 times 0 plus 1/3 squared minus 5/6. Simplifying, we get 5 times 1/3 squared, minus 5/6. Now 1/3 squared is 1/3 times 1/3, which is 1/9. So that's 5 times 1/9 minus 5/6. 5/1 times 1/9 is just 5/9 minus 5/6. And I'm lazy, so I'm putting this in the calculator. You guys can too. If you don't like finding common denominators, it's just, a little tedious. Okay, so I'm doing 5/9 minus 5/6, and I'm getting simplified as negative 5/18. That's my y-intercept here. All right, awesome. Let's do the next one. Separate this out a little bit so you guys can see it better. This is number 1. And number 2, we have g of t equals negative 1/2 times t minus 8 squared. So this time we have a positive 8 for our h value. As we can see here, remember it's the opposite, what you think it is. And then our k, we don't have a k. You see there's no plus something, minus something, so it's actually just 0, right? It's just technically 0. Our axis of symmetry is going to be at x equals h, so this is x equals 8. Concave up or down, we can see that a is -1/2. A negative means concave down. And our y-intercept is going to be what happens when our input is 0. So if we plug in 0 for t, we get -1/2 times 0 minus 8 squared. This is going to be -1/2 times -8 squared. -8 squared is positive 64. -1/2 times positive 64 is going to reduce to -64 over 2, which is, what's half of 64? Half of 60 is 30, half of 4 is 2, so that's -32 is our y-intercept. All right. Cool. All right, great. So we did number 2. Let's do the last one here. So now we just have y equals 4x squared. What is our vertex? Well, it's not really in vertex form, but we can kind of make it look like vertex form. See, I can write this as 4 times x minus 0 squared plus 0, right? Isn't that the same exact thing as this? So that means that h is 0 and k is 0. So h is 0 and k is also 0, so it's vertex is at the origin. Pretty cool. Axis of symmetry is x equals h, x equals 0. Concave up or down? Well, in this case, a is positive, so that's concave up. And our y-intercept happens when our input value is 0. So our y-intercept is going to happen at y equals 4 times 0 squared, which is going to just give us 4 times 0 is 0. So that's our y-intercept here. And it makes sense because we can see it up here as well. Our y-intercept is the same as our vertex. So what I also want you guys to do, I'm not going to do it here in this video, but you should you should put each of these guys in the Desmos graphing calculator. Just Google Desmos graphing calculator. Put in all of these equations. Of course, with the t's, you want to make sure that you put x in there for Desmos, but see if it matches up with what we have here. You know, you should verify that way when you're learning these things. Maybe I'll do this one just to show you guys. Y equals 4x squared. So, or actually, let's do this one. -1/2 x minus 8 squared. So let's see. -1/2, and then in parentheses x minus 8, and then we're going to square that thing. All right, so we can see that the vertex, the highest point of this thing, is 8, 0, which we got. The y-intercept is going to be, we got to zoom out of here and press that. So that's 0, -32. And that's what we got here. So yeah, you should check the, Desmos out to verify these things. The next thing we're going to look at is finding the vertex if it's not in vertex form. So what if it's in standard form like this? How do we figure out the vertex? Well, there's a million ways to do it, but the simple way to do it algebraically is this formula right here. We just take the numbers in our standard form, so we take a and b, and we plug them in to get -b over 2a. That's the h value of our vertex. And then whatever we get when we do that, we stick it into the function to get our output, and that's our k value. So let's do some examples. Let's do this first example. We want to find the vertex of f of x equals 2x squared minus 8x plus 1. So here, this is our a value. So a is equal to 2. And this guy is our b value. So b is equal to -8. Therefore, h is going to be -b over 2a, right, from this formula up here. So we have -8, right? We're plugging in b into that formula, times 2 times a. And a negative times a negative is a +8. over 2 times 2 is 4, and so therefore h is equal to 2. All right, so h is equal to 2. Now to find k, what this f of negative b over 2a means, well, we just found negative b over 2a. That's 2. All we have to do is plug in what we got into our function. So k is going to be 2 times 2 squared minus 8 times 2 plus 1. I'm just evaluating the function at 2 to figure out what k is. So I'm evaluating the function at h. So this is going to give me 2 times 4 minus 16 plus 1. 8 minus 16 plus 1. And what do I get? So I get negative 8 plus 1, which is negative 7. So that's k. So our vertex, for our answer, our vertex is going to be h is 2, k is negative 7. How can we check this on Desmos? All we got to do is put this thing in Desmos. 2x squared minus 8x plus 1. So let's do that. Just to check. Because sometimes we can make mistakes. So 2x squared minus 8x plus 1. All right, we click on the vertex, which in this case is the lowest point because it's concave up. And we can see that the vertex is at 2, negative 7. So h is 2 and k is negative 7. And that's exactly what we got here. So that's our answer. Let's do some more examples. So here, a is equal to 3 over 2 because it's attached to x squared. And b is equal to 4 because it's attached to x. If we use our formula for h, we get h is equal to so h is negative b over 2a. Therefore, in our case, we have negative 4 over 2 times 3 over 2. Now, 2 over 1 times 3 over 2, if I multiply straight across, I get 6 over 2. 6 over 2 reduces to 3. So what I end up getting is negative 4 over 3. For h. So that's h. Now for k, I just need to plug in negative 4 over 3 back into my equation. So for k, we have 3 over 2 times negative 4 over 3 squared plus 4 times negative 4 over 3 minus 5. And let's clean it up. Negative 4 over 3 squared is negative 4 over 3 times negative 4 over 3. If I multiply straight across, I get positive 16 over 9. So that's 3 over 2 times positive 16 over 9. And then here, 4 over 1 times negative 4 over 3 is just a negative 16 over 3. All right, so I'm getting to the point where I might pull out my Desmos scientific calculator online and simplify this. So that's what I'm going to do. I'm going to do 3 over 2 times 16 over 9. So let's see, 3 over 2 times 16 over 9. Desmos Scientific should give you 8 over 3 for this. Then we have minus 16 over 3 minus 5. So let's do that. Minus 16 over 3 minus 5. And simplified, you should get that k is equal to negative 23 over 3. So we have h and k, and therefore we have our answer. So our vertex is at negative 4 thirds, comma, negative 23 thirds, h, comma, k. All right, let's do the next one. So the next one's nice because it's already in vertex form. Vertex form tells us that this is H, and this is K. So we don't have to do any kind of work here. That's nice. So our vertex is just 4, 1. That's our answer. And this was our answer here. All right, for the next one, we do have to do work. This isn't in vertex form. This is in standard form, ax squared plus bx plus c. So, for h, we have negative b over 2a. Well, here, b is equal to negative 8, and a is equal to 1, because it's in front of t squared. So if we plug this into our formula, we get negative 8 over 2 times 1. That gives us a positive 8 over 2, which gives us 4. So h is equal to 4. For k, we just simply plug in h into our function and evaluate. So k is going to be 4 squared minus 8 times 4 minus 1. And I get 16 minus 32 minus 1 equals negative 17. So this is k. Therefore, our vertex is going to be h, which is 4, negative 17. That's our answer. All right, let's look at number 4. So we are not in vertex form here. We're actually in factored form because we can see a 0 here and a 0 here and an a. So this is a, z1, z2. So we need to first FOIL this thing and put it in standard form so we can get a and b. Let's go ahead and do that. So this is factored. We want to go to standard by foiling. So I'm going to leave this negative 2 on the outside and just kind of like, maybe I'll put a bracket here to show that it's just chilling, and then do x minus 4 times x plus 1. So just ignoring the negative 2 on the outside for now. If I FOIL this, first is x times x squared. Outer is x times positive 1. That gives us a positive 1x. Inner is negative 4 times x, which gives us a negative 4x. And finally, last is negative 4 times positive 1, which gives us a negative 4. Combining like terms on the inside, these guys, a 1 and a negative 4, make a negative 3. Took me way too long to do that. X squared minus 3x minus 4. And then we can finally distribute that negative 2 to get ourselves in standard form. So this is going to give us negative 2x squared. And then negative 2 times negative 3x is a positive 6x. A negative 2 times a negative 4 is going to give us a positive 8. And now we're in standard form. And we can see that a is negative 2 because it's in front of the x squared. And b is positive 6 because it's in front of the x. Therefore, h is equal to negative b over 2a. And that's going to give us negative 6 over 2 times negative 2 based on our information. Negative 6 over negative 4 can be reduced. These negatives cancel and we can reduce by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. So h is equal to 3 over 2. To figure out what k is, we simply plug in 3 over 2 into our function. And if you use the factored form, you can do that as well, but I don't know. I'm just going to use standard form to plug in for x. So I get negative 2 times 3 over 2 squared plus 6 times 3 over 2 plus 8. And let's clean it up. Let's deal with that exponent. 3 over 2 squared. 3 over 2 times 3 over 2 is 9 over 4. And 6 over 1 times 3 over 2 is 18 over 2, which reduces to 9. Negative 2 over 1 times 9 over 4 is going to give us negative 18 over 4 plus 9 plus 8. And if I put this in Desmos, or put it in your graphing calculator, whatever calculator will simplify for you. I don't really, I don't like to simplify by hand. It's kind of just, seems like a waste of time a little bit, but I get 12.5, or if you put it in fraction form, it's 25 over 2. So this is K. We got H up here. So our vertex, putting this all together, H comma K is 3 over 2 comma 25 over 2. And that is our answer, you guys. All right, so we want to find the vertex and sketch the graph. We can see that we're in standard form here, and A is equal to 1. We don't have a B, and we don't have a B because there's no X, so that means that B has to equal 0. And so our vertex, H, is going to be negative B over 2A, which is going to simplify down to 0. So H is equal to 0. If we go and plug in that value of H into our function, what we get is 0 squared plus 1, which is going to give us 1 for K. So our vertex is at 0, 1. Cool. So when X is 0, Y is 1. That's where our vertex is. We can also see, so that was the first piece of information that we got. So we got this guy. Now, we can also see that it's concave up. I mean, yeah, so we can also see that this thing is concave up because A is positive, which in this case, A is equal to 1, that number in front of X squared. So that's some good information. We need some more points to make a picture of this graph. And actually, we only need 1 point on one side of the vertex, because then we can just use the fact that this thing's symmetric to get another point. So let's make a little table here. Just a little table. We got X, and then we have our output, which is X squared plus 1. Now, we already got the vertex, which is 0, 1. Now I'm going to pick a point to the right of the vertex. I'm going to pick X equals 1, just to keep it simple. So what happens when X equals 1? What is Y going to equal? Well, we got to plug in 1 into the function. So 1 squared plus 1 is going to give me a Y value of 2. Therefore, we have a point 1, 2 on our parabola. So here's X equals 1. And when X is 1, Y is 2. So this is going to be our other point right here. And we know it concaves up, so it's going to look like this. The other side, we can just reflect the point. Because, okay, so we know that the axis of symmetry goes through the vertex and it divides the thing in half. So this is my axis of symmetry. And that just tells me, if I know that this point is right here, then there's going to also be a point 1 unit away from the axis of symmetry on the other side. I just reflected it. You could put in the other point, you could put in an X value and see what you get out for the Y value using the table, but I think you can just reflect it. That's easy too. So what does this point correspond to? What's our X value? We can see that our X value is -1 and our Y value is 2. So that's another point on our graph. And we can just kind of continue it on like that. So that's a little sketch of our graph right there. Let's do another example. So first thing you want to do is get your vertex. And again, I encourage you guys to pause the video and see if you can do this on your own. So H is -B over 2A. In this case, A is equal to 1/2. That's attached to X squared. and b is equal to -1 because it's attached to x. So if I use my formula here, negative b, I get -1 divided by 2 times a, 2 times 1/2. Now on top, that simplifies just to +1. On bottom, 2 over 1 times 1 over 2 is equal to 2 over 2, which equals 1. 1 over 1 equals 1. So h is equal to 1. K is going to be, we have to evaluate the function at h. So we have to plug in 1 into the original function to see what we get for k. So let's do that. We get 1/2 times 1 squared minus 1 plus 1. That's going to give me 1/2 minus 1 plus 1, which is just going to give me k equals 1/2. All right, so we got our vertex. Our vertex is 1, 1/2. So when x is 1, y is 1/2. That's right here. This is h, k. Maybe I'll put that here. And we know that the axis of symmetry is going to divide this thing in half. So maybe I'll just do this axis of symmetry in orange. Okay. All right, so far so good. Now let's make a little table so we can get another point and reflect that point over so we can get a nice little picture. All right, so if I make my little table here, I get x, and then my output is 1/2 x squared minus x plus 1. Now I want to pick something either to the right or to the left of the vertex. I'm going to pick something to the right of the vertex, which at the vertex we're at x equals 1, so I might as well pick x equals 2 to see what happens. If I pick x equals 2, when I put this in the function, I get this. So maybe I'll do this to the side. 1/2 times 2 squared minus 2 plus 1. Well, 2 squared is 4, so I get 1/2 times 4 minus 2 plus 1. And 1/2 times 4 over 1 is 4 over 2, which is 2. I get 2 minus 2 plus 1, which just equals 1. So when x is 2, our output is 1. All right, so we can plot that. When x is 2, our output is 1. So here is a point right there. Actually, maybe I'll put this h, k under it. This is, well, maybe I'll just put it to the side so you guys can see this. So this is h, k, that's our vertex. And our other point was at 2, 1. So when x is 2, y is 1, this is 2, 1. And we can see that it's concave up because a is positive, so we can sort of connect the dots like that. And then we can use the axis of symmetry to reflect another point in the same position on the other side. So we know that, this first point at 2, 1 is 1 unit away from the axis of symmetry. Therefore, we have another point on the left side, and that ordered pair happens when x is 0, y is 1. So that's that other point we can see on the graph. And we can just connect the dots and give us a nice little beautiful picture of our parabola right here. Our lowest point is the vertex, 1, 1/2, and 2 other points on the graph are 2, 1 and 0, 1. And if you don't like the reflecting thing, if you don't trust it yet, you can always just plug in another x value. If you plugged in 0 for x, then what we would get out for y is 1/2 times 0 squared minus 0 plus 1, and that's going to give us a positive 1, which we can see right here. So that's how you do it. All right, let's forge forge ahead. Okay, so find the vertex. All right, so we need h negative b over 2a. In this case, b is 4 and a is negative 2. So we have negative 4 over 2 times negative 2, which is going to give us negative 4 over negative 4, which gives us positive 1. Excellent. H is positive 1. Now k is just going to be evaluating the function at 1. So we have negative 2 times 1 squared plus 4 times 1 minus 1. So we get negative 2 times 1 is negative 2, plus 4 times 1 is plus 4 minus 1. And this is going to give us a net result of k equals 1. Right? Yeah. So that's cool. So the vertex is 1, 1. So this is h, k, and we can plot it. So when our x is 1, our y is also 1, so this is our vertex. We can see it's concave down because our a is negative, so we know it's going to kind of look like this. But let's be more precise and get some points so that we can connect the dots. And we can get some points with a little rough sketch, a little rough table here. So I want to pick a point to the right of the vertex just to make things simple. I'm going to pick the point x equals 2 to see what I get for y when I put it in there. When I put in x equals 2 into this function, I get this mess. And if I evaluate this, negative 2 times 2 squared, what is this going to give me? Let's see. Negative 2 times 4 is negative 8 plus 8 is 0 minus 1. I get negative 1 for my output. So that tells me when x is equal to 2, y is equal to negative 1. So this is my point that I just found, 2 comma negative 1. And what's neat is that the axis of symmetry divides this thing in half. And so if I have a point this far away from the axis of symmetry, I have this other point on the other side that's equidistant from the axis of symmetry. And that point happens to be at x equals 0, y equals negative 1. You guys can see that? And it's concave down as confirmed with our a value. So we can just go swoop, just like that. Swoop. All right. And again, you can find more points if you want. I didn't specify how many points to find, but remember, guys, a graph has an infinite number of points. We can put in any input we want here. We could put in x equals 0. We could put in x equals negative 1,000,000. I mean, it wouldn't fit on the picture, but you guys get the idea. We really only need 3 nice points to make a good looking quadratic though. So there it is. All right, in this example, we want to find a formula for the parabola shown, and we want to write our answer in standard, vertex, and factored form. All right, so let's just remind ourselves what each of these forms look like. So standard is that y equals ax squared plus bx plus c. And then we had factored, which was y equals a times x minus our first 0 times x minus our second 0. And our third and final form that we learned was vertex. Vertex was y equals a times x minus h squared plus k, where h comma k is the vertex. So we want our answers in each of these forms. All right, how are we going to do it? Well, we want to see what is the easiest form to work with first. I mean, it just, I always go with vertex first because I can clearly see the vertex here. The vertex here is our h is going to be 1 and our k appears to be negative 4. So that's one piece of the puzzle. So let's do vertex first. So we have h is 1, k is negative 4. And then what other pieces of the puzzle do we need? We need to figure out what a is. You're never going to get a from looking at the picture. So what we need is a point, x and y. And once we have those 4 things, we can figure out what a is. So you can pick any other point that is on this graph. I am going to be basic and pick this point because it's the y-intercept. So this point gives me an x value of 0 and a y value of negative 3. That's a point on the curve. I could have also picked this point. I could have picked this point. I could have picked this point. Those are all really nice points to use. Either any of those points could be an x comma y. But I picked the y-intercept just because. I don't know. So here, x is 0 and y is negative 3. And now I can plug in everything that I just found into vertex form. So let's do that. To figure out what a is, we want a. That's the point. So vertex form is y equals a times x minus h squared plus k. Plugging in everything I just found and leaving a alone, I have negative 3 equals a times 0 minus 1 squared plus a negative 4. All right. Now I can just simplify this to clean it up. I still have that a. 0 minus 1 squared minus 4. So I get negative 3 equals negative 1 squared is just positive 1. So this is just a times 1 minus 4. If I add 4 to both sides, I get that. So what I end up getting is 1a equals 1. So a is equal to 1. Therefore, those little 3 dots, therefore a equals 1. Okay, so I just found my first answer. My first answer is y equals a times x minus h squared plus k. So this is vertex form. Remember, with all of these forms, you leave x and y alone as inputs and outputs, but we want to plug in numbers for a and b and c and z1 and h and k. The only things we want to leave as variables are x and y. Okay, cool. So we got vertex form. That's awesome. So let's leave it up here. So we have, I'll just rewrite it. We have y equals, and we don't have to write the 1. I'm just going to leave it off actually in the front for a. Okay, so now what we can do is we can move on to factored form, because this picture actually gives us a nice thing for factored form. So for factored form, we have y equals a times x minus the first 0 times x minus the second 0. And we just established that a was 1. So, and we can see from our picture that we have z1 and z2. So z1 is equal to, it looks like negative 1. And z2 is equal to 3. That's where our zeros are. That's where it crosses the x-axis. And a is 1. So our factored form is just going to be y equals 1 times x minus a negative 1, right? Times x minus 3. This becomes a positive. So our final answer is y equals 1, which I'm not going to write, x plus 1 times x minus 3. So this is our answer in factored form right here. I'm going to erase this. Actually, I'll write the y. All right, cool. Last thing we need to do is find standard form. So standard form, all we have to do is expand this thing, and we can use either vertex or factored. It doesn't matter. We're going to get the same answer either way. I'm just going to use factored because it looks, I don't know, it looks easier. So factored is going to tell me we need a FOIL, first, outer, inner, last, to get into standard. So first is x times x squared. Outer is x times -3, that's -3x. Inner is positive 1 times x, that's positive 1x. And last is positive 1 times -3, which gives us -3. Simplifying this down, we get that our standard form is x squared. -3 and a positive 1 make a -2x minus 3. So this is our answer in standard. This is our answer in factored. And this is our answer in vertex. Okay, so for this problem, we want to find the formula for the parabola shown in standard, vertex, and factored form. Now, if you notice, the vertex isn't really in a great spot because it's not in the corner of a square, so we can't say definitively what this point is. So we need to use another form. And I think the form that makes most sense to find first is factored form, because in factored form we're given the zeros. So first of all, factored form, if you recall, so factored form is going to be of the form y equals a times x minus the first 0 times x minus the second 0. And based on this picture, our first 0 occurs at -1. So z1 is -1, and our second 0 occurs at 4. So z2 is going to be equal to 4. Now let's go ahead and figure out another point on the curve so that we can plug in an x and a y. Well, the most obvious point to use is this one because it's already labeled for us. I mean, there's an infinite number of points that you could use, but this one's labeled, so we might as well use it. Here, our x value is 0, and our y value is -5. So we have x equals 0 and y equals -5. Now let's go ahead and plug in all of these things into factored form to solve for a. So we have y equals a times x minus z1 times x, again is 0, minus z2. These double negatives become a positive here. So we get -5 equals a times 0 plus 1 is just 1. And then 0 minus 4 is just -4. So we get -5 equals a times -4. We can divide both sides by -4 to give ourselves a equals -5 over -4, which reduces to a positive 5 over 4. All right, so now we have factored form. I'm just going to put this right here. So our factored form is going to be y equals, we don't have to write the y because it already says f of x here. Y equals a, which we just found was 5 over 4, times x minus z1 minus a -1 is going to give us a positive 1 here, times x minus z2. So that's our factored form. And remember, with these forms, we want to leave x and f of x as variables, and anything else we want a number for. So like we plugged in a number for a, and we plugged in numbers for z1 and z2, but we left x and y alone. Okay, cool. So we found that. Let's go ahead and now find standard form, because all we have to do is expand our factored form to find standard. So let's go ahead and clean this up a little bit and figure out what this is. So for standard form, all we have to do is take what we got for factored and expand it out to figure out what our answer is. Remember that standard form is in the form ax squared plus bx plus c, where a, b, and c are numbers. So first thing I'm going to do is I'm going to leave the 5 over 4 on the outside, and I'm going to FOIL this x plus 1 times x minus 4. Remember how I do that. I do FOIL is first x times x is x squared. Outer is x times negative 4, which is negative 4x. Inner, positive 1 times x is a positive 1x. And last is positive 1 times a negative 4 is going to give me a negative 4. All right? So from here, I can combine like terms on the inside of the bracket. So negative 4x and a positive 1x makes a negative 3x. And that's all I can combine in there. My last step is to just distribute this 5 over 4 by everybody on the inside. So 5 over 4 times x squared is just 5 over 4x squared minus 5 over 4 times 3 over 1. Multiplying straight across gives me 15 over 4. So 5 over 4 times negative 3 over 1 is just a negative 15 over 4x. And finally, 5 over 4 times negative 4 over 1, multiplying straight across is negative 20 over 4. And doing negative 20 divided by 4 is going to give me a negative 5. So that's my answer in standard form. We can see that A is 5 over 4, B is negative 15 over 4, and C is negative 5. All right, so let's write that down here. Our standard form is 5 over 4 x squared minus 15 over 4x minus 5. Cool. All right, our last one is vertex form. So for vertex form, we need to find the vertex. And let's write it up here. Vertex form is going to be a times x minus h squared plus k. And so there's a few different ways we can do this, but the easiest way I think to find the vertex is to use standard form, because remember the vertex is going to be at negative b over 2a, comma f of negative b over 2a. So looking at my standard form right here, we can see that a is equal to 5 over 4 and b is equal to negative 15 over 4. And using this, I can figure out what my h is, right? H is equal to negative b over 2a. Therefore, in our case, h is equal to negative 15 over 4 divided by 2 times 5 over 4. And we can simplify this down. So these double negatives up here make a positive 15 over 4. And on the bottom, we have 2 over 1 times 5 over 4 is 10 over 4. And if we divide top and bottom by 2, we get 5 over 2. So on the bottom, we have 5 over 2. Now, this is a complex fraction. We have three fraction bars, if you can see. And what we do to deal with that is we keep the top fraction as it is, and then we multiply by the bottom fraction flipped. So flipping 5 over 2 is 2 over 5. And we can cross reduce before we multiply straight across if we want to make it a little easier. So I look at the diagonals and I see what number goes into 2 and 4, what number divides them, and that's 2. 2 goes into itself once, and it goes into 4 twice. Looking at the other diagonal, what number divides both 5 and 15? Well, that's going to be 5. 5 goes into itself once, and 5 goes into 15 3 times. Multiplying the remaining numbers straight across, 3 times 1 is 3. 2 times 1 on the bottom is 2. And so that is our h. H is 3 over 2. So let's write that up here. To figure out what k is in our vertex, we just put 3 over 2 in our function. And we see our function down here. So we have 5. So k is equal to 5 over 4 times 3 over 2 squared minus 15 over 4 times 3 over 2 minus 5. Again, I'm just evaluating the function at 3 over 2 because that's my h. We want to figure out the corresponding y value is there to get k. So here we have 5 over 4. 3 over 2 squared is 3 over 2 times 3 over 2, which is 9 over 4. And then 15, negative 15 over 4 times 3 over 2, if we multiply straight across, is minus 45 over 8 minus 5. So this is k equals. All right, simplifying this out, we get 45 over 16 minus 45 over 8 minus 5. I'm just going to put this in the calculator to see what we get here for k. So I'm getting negative 125 over 16. Okay, so that's k. So k is equal to negative 125 over 16. Let's erase some of the stuff here so we have some room. Okay, so now we have, and we know what a is because we already found a in standard and factored form. We have a is 5 over 4. We just found h and k. H was 3 over 2, and k is negative 125 over 16. Therefore, plugging this stuff into vertex form, we get that vertex form is going to be a times x minus h squared plus k. So that is our answer for vertex form. So it's factored, standard, and vertex form. These all represent the same curve that you can see here in our picture. All right, so find the formula for the quadratic function with vertex 2, negative 4 and y-intercept of y equals negative 3. So it doesn't say find all the forms, standard, vertex, and factored. So here I'm just going to choose one, and I'm going to pick vertex form because we're given a vertex, right? So vertex form is y equals a times x minus h squared plus k, where h comma k is the vertex. And here we're given the vertex. We're given that h is 2 and k is negative 4. We're also secretly given a point x comma y, and that's given from this piece of information that says, hey, the y-intercept is y equals negative 3. So a y-intercept always happens when x equals 0, okay? So this is secretly the point x equals 0, y equals negative 3. All right, so here x is 0 and the corresponding y value is negative 3. And all we have to do is plug in these 4 values in here to solve for a. So let's go ahead and do that. So we have y, which is negative 3, equals a times the corresponding x, which is 0, minus h, which is 2, squared, plus a minus 4, which is minus 4. Let's go ahead and simplify this to get negative 2 on the inside of those parentheses. And negative 2 squared is negative 2 times negative 2, which is just positive 4. And what I can do from here is I can add 4 to both sides to give me that a times 4 is equal to 1. Divide both sides by 4 to give me a equals 1 over 4. Okay, so my formula is y equals a, which we just found, times x, which we leave alone. We always leave x and y alone in our final answer. Minus h, we know h is 2, squared plus k, which is minus 4. So this is my answer right here. All right, let's do some word problems and talk about what the vertex means in these real-world contexts. So first problem, the height of a rocket launched from a cliff 160 feet above ground can be modeled by the equation f of t equals negative 16t squared plus 48t plus 160. We want to know what time does it reach its maximum height and what is its maximum height. Well, the equation that we can see here, this represents height, right? It tells us that this is the height that represents height at time t, right? So this gives us the height at, some t. And we're not really told whether or not t, what the units are, but let's just say t is in seconds. Just, I don't know. It doesn't matter. But we know that f of t is in feet. So what this is showing me, first of all, the a value in standard form is negative. So this tells me that my graph is going to look something like this, right? It's going to be concave down because that a value is negative. And we want to figure out what time it reaches its maximum height and what is the maximum height. That corresponds to the vertex. So this is the maximum height, right? Because the function is it's going to look like this. This is the height function, and the maximum height is going to be the very top. So we need to figure out what that is, and we can do that by using the the formula we use to find the vertex. So vertex h comma k is going to be negative b over 2a, comma f of negative b over 2a. So in our standard form here, we can see that a is negative 16, b is 48, and c is 160, which we don't need here. So in our case, we have negative b, which is negative 48, divided by 2 times negative 16, comma f of, and we can simplify this, negative 48 divided by 2 times negative 16 is going to be negative 48 divided by 32, and that reduced is negative 3 over 2. Or no, this should be positive 3 over 2. I'm sorry, we have double negative. So this becomes a positive 3 over 2. And this is going to be f of 3 over 2. Now let's figure out what f of 3 over 2 is. We just have to plug in 3 over 2 in for our input variable in our boxed equation here. So f of 3 over 2 is negative 16 times 3 over 2 squared plus 48 times 3 over 2 plus 160. And this is going to be negative 16 times 9 over 4, 3 over 2 times 3 over 2. 48 over 1 times 3 over 2, I can cross simplify. 2 goes into itself once. 2 goes into 48. Half of 48 is 24. So 24 times 3 is going to give us 72 over 1, which is just 72. So this is plus 72 plus 160. All right, and I can, again, cross-simplify here. Negative 16 over 1 times 9 over 4. 4 goes into itself once. 4 goes into 16 4 times. Multiplying straight across gives me negative 36 over 1, or just negative 36. Okay. So let's go ahead and simplify this guy. We have negative 36 plus 72 plus 160 is 196. Okay, so our vertex h comma k is going to be 3 over 2 h, and our output was 196. Okay, so let's talk about what this means in the context of our problem. So we said that t was in seconds, even though it doesn't really, say it here in the problem, but this is in seconds. So what does this mean in the context of our problem? Well, we know this thing is upside down parabola, and this is the maximum height, right? So this is 3 over 2, 196. And so what this is telling us, since our input is t, that tells us that at 3 over 2 is 1.5. So at 1.5 seconds, the rocket reaches its maximum height of, well, that's going to be this output value. This height is 196. And we said that the output was in feet, right? So this is going to be a maximum height of 196 feet. So that is what this represents in this context. Okay, let's do another example. This is for you business people. So profit, basically how much money you're making, is going to be given by the money coming in minus how much money it costs to make your products, basically, or keep the business going. So, okay. So the profit is the difference between the company's revenue and the cost. So the cost is represented by C of X in this problem, and the revenue is represented by R of X. Again, revenue is how much money is actually coming in, and C of X is the cost that it costs you to run the company. So these are functions for a particular company. X here represents the number of items produced and sold to distributors. And here we're given these two functions. Now, if you are a business major, you're going to learn later on, or maybe you already know, how these functions come to be. That could be interesting. But for our purposes, we're just interested in using these functions to figure out what the profit function is. Okay, so the first question says determine the profit function. So I'm going to call that P of X, profit, in terms of X. And we're told that, in the little paragraph above here, that it's the difference between the revenue and the cost. So P of X is going to be the profit that I make is how much money is coming in minus how much money it costs to maintain the business. So in our case, R of X is 840x minus x squared. So let's write that. So we have 840x minus x squared minus C of X. Well, in our case, C of X is 2400 plus 40x. Okay, so I'm just plugging in R of X and C of X, and that's going to give me what my profit is. So let's go ahead and combine like terms here. I have 840x minus x squared minus 2400 minus 40x, just distributing this negative to both of those guys. And 840x minus 40x is going to give me 800x. So let me write this up here. I have a negative x squared. I always list my highest power first. And then 840 minus 40 is a positive 800x. And then we have a negative 2400. So this is our profit function. This is P of X. This is P of X. Okay. So determine the maximum profit of the company. All right. And then the next question says determine the number of items that must be sold to obtain the maximum profit. So our profit function is this. It's negative x squared plus 800x minus 2400. And we're not sure what this looks like exactly, but we know that it's a parabola because the highest power is 2. And we have, we also know that it's an upside down parabola because this A is negative 1. And so it's going to look something like this. Now the maximum profit, so this is P of X, profit in terms of X. So the maximum profit is going to happen at the top of this curve. Just like the maximum height occurred at the top of the height curve, the maximum profit is going to occur at the top of the profit curve. So we can use our vertex to figure out what that is. And we're given this thing is in standard form, right? Here we have A is negative 1. We can see that. B is 800 because that's the number attached to X. So H is going to be negative B over 2 times A. which is going to give us a net result of 400. So that's that. And then k is just the function evaluated at h. So we have to plug in h into our profit function here for x. So if I plug in 400 anywhere I see an x, I get negative 400 squared plus 800 times 400 minus 2400. And this is going to give me a net result of, let's see. Okay, so this is going to give me 157,600. So that's K. So this maximum profit occurs at 400, 157,600. This is H, K. So let's interpret what these numbers mean. What was our input? What was our input here? Well, our input is X, right? Because it's a function of X. That's our input. And we're told that X represents the number of items produced and sold to distributors. So here, what this is telling me, this is my X, the H. This is telling me that the maximum profit is what? Well, that's going to be the output. That's how much money we made for 400 items sold. So $157,600. That's our answer for part B. And for part C, it's asking this part, how many items did you sell to obtain that maximum profit? And that's 400. So 400 items. And that is, that's both of these represent that vertex right there, part of that vertex. Okay, let's do one more problem. So the hypotenuse of a right triangle is 6 more than the shorter leg. The longer leg is 3 more than the shorter leg, and so we want to find the length of the shorter leg. Let's go ahead and draw a picture. So we know we have a right triangle. So here's our right angle. And the hypotenuse is the side across from the right angle. So it's 6 more than the shorter leg. Which one do we want to make the shorter leg? Let's make the shorter leg this one, and let's call it X. We don't know what it is. So this is the short leg. And if the hypotenuse is 6 more than the short leg, that means it's just going to be the short leg plus 6. They then tell us the other leg, the long leg, is 3 more than the shorter leg. So if this is the short leg, then this must be the longer leg. And we're told that it's 3 more than the shorter leg, so it's going to be the short leg plus 3. And so what we want to figure out is what is the length of the shorter leg, or what is X basically, is what they're asking us to find. So how do we deal with right triangles? We deal with right triangles using Pythagorean theorem. So Pythagorean theorem tells us a squared plus b squared equals c squared when we have a right triangle. Okay? C is always the hypotenuse, which is across from the 90-degree angle. So if we use the Pythagorean theorem in our case, we get a is x, so we get x squared, b is x plus 3, plus x plus 3 squared equals hypotenuse squared. Our hypotenuse is x plus 6 squared. Okay? And here what we can do is we can just mess around with it and expand it out. So x plus 3 squared is just x plus 3 times x plus 3. And And same thing for x plus 6. It's just x plus 6 squared is x plus 6 times x plus 6. And we can FOIL these binomials out. So over here, if we do first, outer, inner, last, first, x times x is x squared. Outer, x times 3 is positive 3x. Inner, 3 times x is positive 3x. And last, positive 3 times positive 3 is positive 9. On the right side, we can do the same thing. X times x is x squared. Outer, x times positive 6 is positive 6x. Inner, positive 6 times x is positive 6x. And last, positive 6 times positive 6 is positive 36. All right, let's go ahead and combine our like terms. So here 1 of something plus 1 of something is 2 of something, 2x squared. And then positive 3x and a positive 3x makes a positive 6x. Positive 9 can't really go anywhere, so we just carry that down. And then over here, we get x squared, 6x and 6x makes 12x. And then we can't really do anything. So what I can do from here is I can, move things over to other sides and combine like terms that way. So the first thing I notice is I have a 2x squared over here and an x squared over here. So I can kind of combine those by subtracting x squared from both sides. So 2 of something minus 1 of something is just 1 of something. And I can carry everything else down. Okay, let's see. It looks like I have a trinomial, so chances are I'm going to have to either factor or use a quadratic formula. So remember, when we do that, we want one side to equal 0. So that's what the strategy here is. I'm trying to make one side equal 0. So I want to go ahead and subtract over this 12x first. And then I want to subtract over the 36 to give me 0 on the right side. So what I have is x squared. 6 minus 12 is giving us a negative 6x. And then 9 minus 36 is giving us a negative 27. Okay. All right. So now I think we can, let's see, can we factor this? Well, let's see. We want to find two numbers that multiply to negative 27, yet add to negative 6. Can you think of two numbers that will do that? Let's try. So we have this. Negative 9 and positive 3 will do the trick, right? Negative 9 times positive 3 is negative 27, but negative 9 and positive 3 also makes a negative 6. So those are the magic numbers there. All right. Now we can set each of these factors equal to 0. So we have x minus 9 equals 0 and x plus 3 equals 0. So we get x equals 9 and x equals negative 3. So we can throw out this answer because, look, x is the short leg, and it doesn't make sense for us to have a negative length, okay? What did we want to do? We wanted to find x. We wanted to find the length of the short leg, and we got it. We got that x is equal to 9. So this is our answer here.